pH. pH is an indicator that we use to indicate or tell the acidity of a solution. What is pH? pH is calculated by the negative log the H3O plus concentration. pH equals to negative log H3O plus concentration, or simply we can say the negative log of H plus concentration. So, we use the ionization of water, pure water at 25 degrees of Celsius. Their concentration of a hydronium ion equals to the concentration of hydroxyl ions equals to the 1.0 times 10 to the negative 7. So let's convert that into pH. Negative log 1.0 times 10 to the negative 7, which is equal to 7. So the pH of pure water at 25 degrees of Celsius is equals to 7.00. As the solution is neutral, the pure water at 25 degrees of Celsius, the water is neutral, and therefore a neutral solution has pH equals to 7.00. Acidic solutions have pH less than 7. The basic solutions have pH greater than 7.00. Also, if we are given the pH value, we can calculate the hydronium ion or the H plus concentration using the pH value. Then we get the 10 to the negative pH value. That's how we'll calculate the hydronium ion concentration when we are given the pH value. Here you will see some other benchmark pH values for a range of hydronium ion concentrations at 25 degrees of Celsius. As simply when 10 to the negative 1, the pH equals 1, 10 to the negative 2, pH 2, 10 to the negative 3, pH 3, like that. So all these solutions less than 7 are acidic, at 7 it is neutral, above 7 are basic. Your turn. Determine the pH of a solution at 25 degrees of Celsius in which the hydronium ion concentration is given at we are given the different values, so we need to calculate. So what is the pH? How we can calculate the pH? pH equals to the negative log H3O plus concentration. So we are given the H3O plus concentration. So we plug those values as in the H3O plus concentration for 3 different conditions. Then we solve that and we get the pH values as the answers. So you need a scientific calculator to do the operations. Another practice problem. Calculate the hydronium ion concentration in a solution at 25 degrees of Celsius in which the pH. Now we are given the pH and we are asked to find the H3O plus concentration. What is the equation? Yes, H3O plus concentration equals 10 to the negative pH. That is the equation. So we can plug the given pH values for 3 different conditions, and then we'll calculate the H3O plus concentration. Again, you need a scientific calculator to do these operations. Next, we talk about the pH scale. What is pOH scale? Yes, it is just the same as in the pH, but instead of the concentration of hydronium ions, now you use the concentration of hydroxyl ions. pOH equals to negative log hydroxyl ion concentration. When we are given the pOH value, we can calculate the hydroxyl ion concentration by taking the 10 to the negative pOH value. So here, when we look at this, the operation, the when we consider the ionization of water, so it is like the negative log H3O plus concentration, like this. Let me write that H3O plus concentration times the OH minus concentration equals the 1.0 times 10 to the negative 14. That is the Kw, right? So let's I am taking the negative log values of the equation. Then when the negative log H3O plus concentration is actually the pH. Negative log OH minus concentration is actually the pOH, and that is equals to the 14. So pH plus pOH equals 14. So pKw, what is then pKw? Yes, it is equals to 14. Here you will see some again the pOH values and the OH minus concentrations here. And when it is above uh, pOH, now in the consideration of the pOH is when the pOH is less than 7, it is basic pOH. This is pOH scale, not the pH scale. And again pOH, when pOH equals 7, it is neutral. When the pOH is greater than 7, it becomes acidic. This is pOH. No need to remember two different things. Just remember the pH scale. The pOH scale is just the opposite of the pH. Your turn. Determine the pOH of a solution at 25 degrees of Celsius in which the hydroxide and concentration is. Now we are given the pOH concentrations and we need to find the, hydroxyl ion concentrations, hydroxide ion concentrations, and now we need to find the pOH. pOH equals negative log OH minus concentration. So we plug those values and we calculate the pOH for three different conditions. Next question. Calculate the hydroxide ion concentration solution at 25 degrees of Celsius in which the pOH equals. We are given three different conditions. So how do we find the hydroxide ion concentration when we are given the pOH value? OH minus concentration equals 10 to the negative pOH. So you plug those values and you calculate the hydroxyl ion concentrations.